Hello everyone and welcome to Leetcode 27, remove element. Here we're given an integer array nums and an integer val. We have to remove every single occurrence of val in nums and we have to do it in place. What in place means is that we have to do it with constant memory, right? We can't create, say, a list 2 and then add every single value other than val. So what would we do in this situation? Let's look at the example to understand this a bit better. Here, the val we're given is 2, and in this list, 2 occurs 3 times, right? And essentially, we just want a list where the 2's are not present. And when we look at the solution, we understand that, okay, it's quite different in that it's not in the same order as the problem, right? If we were to simply remove the 2's, we'd have 0, 1, 3, 0, 4. But here we have 0, 1, 4, 0, 3. So when we observe the solution here, we notice that, okay, the numbers before the first two are the same, right? 0, 1 and 0, 1. But after that, 3, 0, 4 comes in reverse order. So we have, instead of 3, 0, 4, we have 4, 0, 3. And what this tells us is an interesting method to do this question. It tells us that we can replace the 2's with numbers from the back, right? We can replace the first 2 with the last number and the second 2 with the second last number, and so on. Remember that we don't consider this 2 as the last number because, you know, it's a 2. We don't want to replace 2 with 2. That is nothing. So this is a simple solution that we can do where we iterate through the list like this, checking for if a number is 2, and we can iterate through the list backwards to check for numbers that can replace this 2. And ultimately, after we're all done replacing, our result list should look something like this, right? And since when we iterate forward, it's gonna stop at 3 because that's when both the iterations will meet, we will have 5 elements, right? Oh, that's weird. We will have these 5 elements over here. It'll become 0, 1, 4, 0, 3 as we see in the solution, right? And this value is what we have to return. See here it says return k, so let's just say k equals 5. So let's code up the solution where we have a pointer going forwards checking for 2's and a pointer going backwards checking for numbers to replace the 2's. So first of all, let's have the 2 pointers that I said. So we have k equals 0, which will iterate from 0 till a certain point, and we have n, which is equal to len of nums, which will iterate backwards to a certain point. Now this certain point that I did mention in my example is the point where k and n are the same, right, when they coincide. Let's scroll down to example, right, and we see that this is the point where they will meet. And that's where the code needs to stop. As we can see from the example, we only have the numbers up till 3 because in the modified list all the numbers after this would be 2, 2, 2. So to check for this condition each time, we're gonna have while k is less than n. Now what do? Well, k is supposed to iterate forward, so let's just check if nums k is equal to val. And once we know that a number is equal to val, let's go back to example over here. And once we can see that our number is equal to val, we're gonna want to replace it with the last number, right? So let's assign a value to this as nums of n, and I'm gonna put -1 because that's how iteration works, right? If I put n, it would just give an error. So, and at the end, let's also increment n by -=1 because, you know, we're just replacing a number with n, so we can move on to the next iteration. And since it's backwards, we can do -=1 instead of +=1. So we've covered the case of when it equals 2, right? So what if it's not equal to 2? Let's just make an else statement. And if it's not equal to 2, well, there's nothing much to be done. We just go on with our day and keep checking the next and next elements until we find a 2, right? So we can just add 1 to k. So if we just look at our example, right? So at the starting, k will be equal to 0, and after it looks at this index, it'll realize, oh, okay, that's not 2, let's update. It'll go to index 1, it'll go to index 2, and it'll go to index 1, and then it's going to see that this number, oh, that's a 2. That means that we need to check our n minus, that means we need to check our n. And at the starting, n is going to be equal to 2, and it's going to replace 2 with 2, and that's inefficient, but it still works. The code still works out in the end. So once, look at the code for a second, right? Once we replace the 2 with 2, our n gets backward incremented, which means that it'll become 4 now, right? And then 4 replaces the 2. After that, we move on to this. 0 replaces the 2. And then finally, we can upgrade our, and then finally, we can increase our k value. So at the end, all we're gonna want to do is return the value of n, because it's gonna stop at this, and that's what we need. So let's just submit the solution. And there we go. Thank you so much for watching.